Okay, so for today, we're going to look at exponential and log derivatives. So take a second and write these down. What you're looking at here is that this the derivative of e to the x is just e to the x. If there's something in that exponent besides x, we'll also take the derivative of that and multiply it by that e to the x. The derivative of natural log, ln x, is going to be 1 over whatever's inside that log. You also need to take the derivative of what's inside that log and multiply it. Okay, so looking at these two examples. For number 1, we have this e to the x, e to the 4x minus 1. So this 4 is just going to stay. So I'm doing the derivative. So the derivative of this e to the 4x minus 1 is just e to the 4x minus 1 times the derivative of what's in the exponent, which the derivative of 4x minus 1 is just 4. I'm going to multiply the 4 and the 4 to get 16e to the 4x minus 1. Okay, number 2, e to the x cubed. So the derivative of e to the x cubed, we just put e to the x cubed. Then I take the derivative, f prime of x. Then I take the derivative of x cubed, and that's 3x squared. I multiply it to that e to the x cubed. I'm going to put this out front. And there's the derivative. Okay, looking at some natural logs. Okay, we saw that the derivative of a natural log, so again, I'm just going to put this 2 out front, and I'm just focusing on this natural log part. You take what is inside the log, and you put it 1 over that expression. Then I have to take the derivative of that and multiply it. So the derivative of this, well, that derivative of 1 is 0. Negative 3x, that just becomes negative 3. 2x squared becomes 4x. We can think about that like over 1, and this 2 is over 1. So we can multiply the numerators and multiply the denominators. Okay, so I'm going to put the x first here when I multiply these two, because I would get negative 6 plus 8x. I'm going to put 8x minus 6 over that denominator. And there's the derivative. For number 4, f of x equals ln square root of x. I'm going to write this as ln x to the 1/2. So the derivative here is just 1 over what's inside your natural log times the derivative of what's inside the natural log. So I'm taking the derivative of this. I move the 1/2 out front. Minus 1 from that is negative 1/2. So this negative gets pushed into the denominator. So what we're looking at, I have this 2 in the denominator. I have this x to the 1/2, and now I have this x to the 1/2 because it had a negative exponent. Multiplying two things with the same base, we add the exponents. So that's going to become x to the 1st. So it looks like that, 1 over 2x. Okay, we're going to remember some log properties here and make these a whole lot simpler. You can work these out like with the properties we saw where you're doing the derivative of e and then what's the derivative in the exponent and keep going from there. But when we have, let's first talk about when the base is e and the exponent has a natural log in it. Both of these examples are like that. When this happens, so your base is e, and we have a natural log here, so the base of that natural log is e. When these bases match, when this matches this, it is equal to just what is inside the natural log. So this function simplifies to this. We have not taken the derivative yet. But again, the base is e, the base of the natural log is e, so we get to just grab that 2x. The derivative of this is just 2. So seeing that same property here, we have base e, and we have a natural log in our exponent. So as an understood e, when those match, this function just equals what is inside the natural log, which is x squared. So the derivative of x squared is 2x. So that's one property we got to remember. Let's look at the other one. When we're taking the natural log, and we have an e inside of the natural log. So, the power property says we can move this out front and multiply it with this 3. So then I just have L and E. So this becomes 6x. The natural log of e equals to 1, because when the base of a log matches what's inside the log, that just equals to 1. So there's our function simplified. So the derivative is just 6. Okay. So again, natural log of e just equals to 1. So I'm going to do the same thing here. I'm going to move this out front using the power property. Put it in parentheses. Natural log of e equals to 1. So f of x is just x squared plus 2x. Taking the derivative, I get 2x plus 2. Okay, and that's it.